Hi guys, this video is going to go over the Section 8 review. So let's get started. So number one of the review wants us to, and actually for 1 through 18, we need to write the exact answers. No decimal approximations are allowed here. So notice that the first question is asking us to evaluate 400 to the power 1 half. Power 1 half means that 400 has the power 1 and the index on the radical is 2. So this is the square root of 400, which can break up into the square root of 4 times the square root of 100. And since the square root of 4 is 2 and the square root of 100 is 10, then that means it's 2 times 10, which is 20. Okay, next on number 2, we have simplify 3 times x to the power negative 1/4. Now, the power negative 1/4 only applies to the x, since 3x is not in parentheses. So 3 has a power of 1. So this is 3, and then I'm going to move x to the negative power as a positive power in the denominator, since I cannot have any negative exponents in my final answer. Now, there's nothing else I could do here, so that's it for number 2. On number 3, we have 2/5 to the power negative 2. Now, the 2/5 is in parentheses, so the 2 has the power negative 2, and the 5 has the power negative 2. So since those powers are negative, we're going to switch them. The 5 will go with a positive power of 2 on the top, and the 2 will go with a positive power of 2 on the bottom. So all I did was change the powers to a positive, but then I switched the side of the fraction that it's on. So this means it's 5 squared, which is 25, over 2 squared, which is 4. And that fraction can't be simplified, so that is it. The next one on number 6, we can start by moving the powers that are negative to the opposite sides, as well as simplifying the 15 over 3, which would be 3 over 1. So we have a 3 in the numerator, and then I'm going to go ahead and move a to the power negative 9 to the numerator as a positive power. The b to the power of 2 was already in the numerator, and then that will be it for the numerator. On the denominator, I will move down the a to the power negative 3 as a positive 3, but move it to the denominator, and the b to the power of 6 was already in the denominator. The next thing I could do is I can cancel out common copies. So for example, we have 3 copies of a in the denominator. So I can cancel that out with 3 copies of a in the numerator, meaning that there are 6 copies in the numerator. Another way to do that is by using the quotient rule, which says that you subtract the powers when you're dividing. So I would do 9 minus 3, which will give me power of 6. I could do the same thing with b. B to the power of 2, so 2 copies in the numerator, cancel that out with 2 copies in the denominator, means there's 4 copies in the denominator. And again, another way that I could have done that is 2 minus 6, which would have given me b to the power negative 4, which is why b to the power of 4 ends up in the denominator, not the numerator. So in the numerator, I have 3a to the power of 6, and in the denominator, I have b to the power of 4. Now, since there is a variable in the denominator, it's a good idea to go ahead and write that b cannot equal 0. And again, this is because when I have a variable in the denominator, because division of 0 is not allowed in math, then that means that any value that will make the variable in the denominator 0 is not allowable and it's excluded. Okay? All right, move right along to number 7. So on number 7, we have the cube root of negative 108. Now, I can split up 108 into 4 times 27. 4 times 27 does give me 108. And obviously, it's negative 108, so I can go ahead and put the negative on either 4 or 27. I'll put it on the negative 27. Because 3 copies of negative 20 that multiply to negative 27 would be negative 3. And since this is a cube root, these 3 copies of the same number, that number goes out of the cube root. So we have just a regular negative 3 and then multiplied by the cube root of 4. Again, that's because the cube root of negative 27 would be negative 3. And of course, the cube root of 4, since 4 is not a perfect cube, it just stays the cube root of 4. So this would be the simplest form for that radical. All right. Next up, number 4. So again, remember, we're going to simplify here. So the first thing that I'm noticing is we do have a cube root, and that cube root is over the entire fraction. So I'm going to go ahead and split up the cube root of the numerator over the cube root of the denominator. When I do that for the numerator, I can use my fraction exponents to switch it to a to the power of 12 over 3 times b to the power of 4 over 3. And since the denominator is a number, I will keep it as a radical for now. And so now you could see that in the numerator, that'll simplify a to the power 12 over 3 to just a to the power 4. And then b to the power of 4 over 3 would mean that I have one whole copy of b and then 1/3 copy that remains. So b to the power of 4/3 is the same as b to the power of 1 and then the cube root of b. Now, I'm almost done here. The only thing is that I cannot keep a radical in the denominator. So since this is a cube root, I will multiply by 2 more copies of the cube root of negative 2. Because 3 copies of that same number means that you just have that number as a whole number. So of course, if I do that to the bottom of the fraction, I also need to do that to the top of the fraction, which means I'm really multiplying by the cube root of 4, since negative 2 times negative 2 is positive 4. So my final answer would be a negative fraction, a to the power of 4, b, and then under the cube root, we would have the 4 and then the b. And I can keep that negative in the denominator, or I could put it on the front of the fraction, or I could put it in the numerator as well. All right, for number 5, we need to write this in both radical and exponential form. So for number 4, I wrote my final answer in radical form, but you can write it with a fraction exponent instead. So number 5 is asking us to do both. So first, again, I will start by distributing the radical to both the numerator and the denominator. So I'm going to go ahead and split up the square root of 75, x to the power of 5, y to the power of 6, and then do the same thing for the denominator. Split up square root of 36, and then x. So next, what I will do is I will use the same strategy of changing it to the fraction exponents. So 75 to the power of 1/3, or 1/2, excuse me, because this is a square root, not a cube root. And then x to the power of 5/3, 5 over 2, and then y to the power of 6 over 2. On the denominator, same thing, 36 to the power of 1/2 and x to the power of 1/2. All right, so now that I've done that, I can go ahead and actually simplify the 36 to the power of 1/2, which would be the square root of 36, which is just 6. And I can also combine the x that I have on the top and the bottom here. So I have x to the power of 5 over 2. And since this is the quotient rule, I will subtract the 5 over 2 and the 1/2. So that means I have x to the power of 4 over 2, which would be just x to the power of 2. And then the y to the power of 6 over 2, that would be y to the power of 3. Right, and then last step is I need to simplify the square root of 75. So 75 does break up into the square root of 25 times 3, since 25 times 3 is 75, and the square root of 75 is 5 times 5. So we have a 5 that is going to come out of that radical, and the 3 is going to stay in the radical. So this would be my radical form. And the other question is asking me to write it with an exponent. So that would be 5. And then 3 is the only one that would have a power 1/2. And then x power 2 would stay, y power 3 would stay, and the 6 in the denominator stay. So when I'm writing in an exponential form, I just write it with fraction exponent form. I just take all my radicals and I write them as fraction exponents instead. Okay, let's move on to number 8. So on number 8, they're wanting us to simplify and write it in exponential form specifically. So we have here a negative, but it's on the outside of the radical. So that means that negative is just going to stay there the whole time. I have the 72, which I to 36 times 2. Since this is the square root of 72, I want to get a perfect square so that I can take that square root of 6 out of that radical. So I'm going to have a 6 that comes out of the radical, and then a 2 that stays in the radical. And then I also have m to the power of 11. So since this is a square root, then it will be m to the power of 11 over 2, which we would then split up. There are 11 divided by 2 will be 5 whole copies of that comes out, and then we have 1 copy that's going to remain on the inside because 11 over 2 is 5 and 1/2. So to write it in radical form, it would just be -6 times the 2 to the power 1/2 times the m to the power of 5 and times m to the power of 1/2. Or you could put your whole copies in front, the -6 times the m to the power of 5, and then the 2 to the power of 1/2 and the m to the power of 1/2. You could write it that way as well. And then to write it in radical form, we would definitely put our whole copies in front, and then the radical, which is going to be with the 2 to the power of 1 and the m to the power of 1 behind it. The question did ask me, though, I'm just realizing now that it didn't ask for both. If it asked for radical form, then this would have been the answer, but it asked me for exponential form, so the answer is this one here. Or you could also write it as this one here. Right. Next up, we have number 9. Now, on number 9, we do have this power -1/2, which is outside of the parentheses. So that means that the numerator, m to the power 2, also has the power of -1/2, and the denominator, m to the power 1/3, also has the power -1/2. So in the numerator, 2 times -1/2 will be -1, and in the denominator, 1/3 times -1/2 would be -1/6. Now, since I have negative powers, obviously I need to change the side of the fractions that they're on, would be a good idea here. So I can put m to the power 1/6 on the numerator and m to the power of 1 in the denominator. And then I can use the quotient rule to subtract. So this would be m to the power 1/6 minus 1, which if I do 1/6 minus 1, that's going to give me a negative 5/6. And normally, right, we would just be done at this point, but remember, you cannot have a negative power. So then what I'm going to do here is I'm going to move over the m to the power of 5/6 as a positive in the denominator, and would just be 1 since there's nothing that would remain. The coefficient of m to the power negative 5, 6 is 1. So this would be the answer if the question was asking for a fraction exponent or an exponential form, the rational exponent. However, if we actually look at the question, it did ask us to write it in radical form. So this means that we can't have a radical in the denominator at all. And if we did that, we would have then 6th root of m to the power of 5. So we cannot have any radical in the denominator at all, which means that we can actually go back to this step here, which was the last step that did not have a radical in the denominator, and use this one. So this is the only time where you can have the same variable in multiple places. And it's when you do it in radical form, just because of the more important rule that you cannot have any radical in the denominator. So in radical form, my answer would be, since this one did not have any radical in the denominator, it will be the 6th root of m over m. And this would have been the answer if they asked me for the exponential form or the rational exponent form. Next up, number 10, evaluate the expression. We have 9 over 16 to the power 3 over 2. Okay, so that means that a 9 has the power 3 over 2, and also 16 has the power 3 over 2. So this would be 9 to the power 3 over 2. I could actually use my calculator to determine that. So if I raise 9 to the power and then the fraction 3 over denominator 2 is 27. And then for the denominator, 16 to the power of 3 over 2, which is really 16 to the power 3 and then the square root of that, right? So that gives me 64. And then, of course, I would try to simplify 27 over 64 if I could, but in this case, I cannot, so that's my answer. All right, for number 11, we're going to simplify and write it in radical form, specifically they want me to do. So notice that this is in parentheses, so the power 1/5 applies for the 64, and it also applies to the x power 2. So it will be x to the power of 2 times 1/5, which is 2/5. Simplify negative 64 to the power of 1/5. We can break up negative 64, which is 2 times 32, and 32 is 2 times 16, and 16 is 2 times 8, and 8 is 2 times 4, and of course 4 is 2 times 2. Now, since this is the 5th root of negative 64, we are looking for 5 copies of the same number, and then we can take that number out of the radical. So negative 2 times negative 2 times negative 2 times negative 2 times negative 2. So I have 5 copies of negative 2, since it does have to multiply to a negative 64. So I have 5 copies of negative 2, so I could take a negative 2 out of the radical, and then inside of the 5th root, I will have just 1 2 that remains. They are asking me to write it in radical form, so I'm going to keep it like that instead of writing 2 to the power of 1/5. And then with the x to the power of 2/5, so that means that under the 5th root, there's also 2 copies of x squared. And so this would be the radical form in simplest form. All right, for number 15, we have the 5th root of 1920 over 10. So we're going to go ahead and split up the 5th root of 1920 over the 5th root of 10. So we can apply the same strategy to simplify 1920. So 1920 divided by 2 would be 960, and 960 divided by 2. And I can always use my calculator to do this. Obviously, an even number would always be divisible by 2. So I could do 960 divided by 2 and just confirm it on my calculator if I need to. So that's 480. And then 480 would split up into 2 times 240. And then 240 would split up into 2 times 120. and then 120 would split up into 2 times 60, and 60 would split up into 2 times 30. 30 is 3 times 10, and 10 is 5 times 2. Or I could have done 30 back here would be 2 times 15, and then 15 is 3 times 5. So we still end up with all of the same prime factors. Now remember, this is a fifth root, so 5 copies of the same number comes out. Anything that doesn't have a group, right? So anything that's not in this group of 5, then will just stay inside of the radical. So we have 5 copies of 2, so that means 1, 2 is going to come out from that fifth root. And then we have a 2, 2, and 3, and 5. So 2 times 2 is 4, times 3 is 12, and 12 times 5 is 60. So we're going to have a 60 that is going to stay on the inside because there aren't 5 copies. Then on the denominator, we have the fifth root of 10. Now 10 is really just 5 times 2, right? So there's no 5 copies. So this fifth root of 10 would stay in the denominator, and that cannot be simplified at all. Now, again, normally we would circle this answer, but let's take a look at what we have here. We have here the fifth root of 60 over the fifth root of 10. And since both of those are fifth root, right, I can put them together as a fraction. Just like I can separate the fifth root, right, I could also bring it back together. So this would be the fifth root of 60 divided by 10, which of course 60 divided by 10 is 6. So we end up with 2 times the fifth root of 6. All right, moving right along for number 16. We have the square root of 49 over the square root of 2. Now, obviously, the square root of 49, that's 7, since 7 squared is 49. And then in the denominator, the square root of 2, that cannot simplify because 2 is just 2. However, remember, you cannot circle this as your answer because you cannot have a radical in the denominator. So what I can do is I can multiply by the square root of 2. That way, since it's a square root, 2 copies of 2, a whole number 2 will come out of that. But of course, I have to multiply my numerator by the same thing so that the fraction remains equivalent. So my final answer here would be 7 square root of 2 over 2, or 7 over 2 times square root of 2. Okay, next up we have number 12. And notice that we have multiple radicals here. They do want me to write my final answer as exponent form with the fraction exponent. So we're going to work from the inside out. So we're going to change the square root, right, is going to be whatever is on the inside, which is m plus 1, which has a power 3. And the square root means that that power 3 is going to be divided by 2. Then we have the fourth root, which we know is going to be the 1/4, right? So we have here two powers. Power of a power multiplies together. So we're going to multiply those two together. 3 times 1 is 3. 2 times 4 is 8. And 3/8 does not simplify, so this is our final answer. And they did want me to write it as a fraction exponent, exponential form. So this is it. All right, on number 13, notice that we have multiple x's. So the first thing that I can do is I can combine the ones on the numerator. We know that the product rule says that we add the powers. So I'm going to do x, and then I'm going to add 6a plus the 3a minus 1. So clearly there, we combine the 6a and the 3a, giving me 9a minus 1 in the numerator. And the denominator, for now, we could just write it down. Okay, then we can apply the quotient rule. The quotient rule says if you're dividing the same base, then you subtract the powers. So now this will be x to the power, and it'll be 9a minus 1 minus the denominator power, which is negative 3a plus 7. Now, you cannot forget to make sure you distribute the negative. So this is going to be 9a minus the negative 3a, which ends up being a double negative, so that's a positive. So 9a plus 3a, which is 12a. And then negative 1 minus, you got to distribute that negative there as well. So negative 1 minus the 7 is negative 8. And that's it. Okay, next up, number 14. They're asking us to find the product of m and n. Okay, in order to find the product of m and n, I first have to find what is m and n. So let's do this. Notice that we have both radical form and fraction exponent exponential form. So the very best thing to do here would be to get them all to be the same form. So I'm going to first just go ahead and split the radicals to fraction exponents. So that would be m divided by n. On the right side, this would be 7/5/8, and then times 7, which has a power of 1, and that's the square root, so we would divide it by 2. So now we have here on the right side the multiplying the same base. So remember, when you're multiplying the same base, you can add the powers. So I can use my calculator here so that I could quickly add 5/8 plus 1/2, and that's 9/8. The left side I am writing down, but I do want to get the term that has the variables in the power by itself. So what I need to do is I need to divide by the 7 to the power 3/4. So I can get 7 to the power of n over m by itself on the left side. Now, of course, if I divide the left side by 7 to the power 3/4, I have to divide the right side by 7 to the power 3/4. And remember, the quotient rule says if you're dividing the same base, you're going to subtract the powers. So I can use my calculator here, again, to do some quick fraction operations and do the two fractions subtracted together. So that gave me 3/8. 7 to the power 3/8, of course. Now, if 7 to the power is equal to 7 to some power, then those powers have to be equivalent. M over n must equal 3/8, which means that n equals 3 and m equals 8. Now the question asks me, what is the product? So 3 times 8 is 24, and that is the product of the two. So my answer here is 24. Okay, number 17. Okay, for number 17, we have the 7th root here. So I'm going to go ahead and apply that 7th root to everything under the radical. So x to the power of 14 is going to have the 7th root, which means divide the power by 7. And then y to the power 21 also has the 7th root. And z to the power negative 35 is also under that radical, so it also has the 7th root. Now I can go ahead and simplify each of those powers. So x to the power of 14 divided by 7 is just 2. Y to the power of 21 divided by 7 is 3. And then in the denominator, negative 35 to the power divided by 7 is negative 5. Now, I would normally circle this, but remember, you can't have any negative powers. So I'm just going to change that z to the power negative 5 to z to the power positive 5, but I'm going to switch it from the denominator to the numerator. So my final answer would be x to the power of 2 times y to the power of 3 times z to the power of 5. All right, and the last one from these type to go ahead and simplify as to write the exponential form for number 18. So notice that we do have that third root. So that means that xa plus 1, which has a power of 2, since that's under the cube root, that means that that we're going to have that power divided by 3. Now, I can't circle this because I can actually simplify further by doing the power of a power rule. That means you multiply the two powers together. So it's going to be a plus 1 multiplied by the 2/3, which I would distribute the multiplication to both terms. So I will get 2/3 a plus 2/3. And that's the answer for 18. Okie dokie. Moving along, number 19. Okay, for number 19, we're going to solve the equation. Remember, to solve the equation, we want to get the radical by itself first. So my first step is to go ahead and subtract 9 on both sides. So now we have the square root of 3x plus 10 equal to -8. Now, as I go here, I can go ahead and continue to solve this by squaring both sides and then getting a solution. But this is actually going to end up having no real solution, because if you really think about it, there is no number for x that when I square root it is going to give me a negative. Okay? Now, for the sake of the argument, I'm going to go ahead and continue and finish solving it, because remember, this won't work for all radicals, but you can use this strategy really for the square root, since obviously any even root cannot end up being a negative, since you can't, when you multiply even amount of negatives together, there will be positive. But just for the sake of the argument, we're going to go ahead and finish solving this. So we're going to square both sides. So that means I'm going to have 3x plus 10 equal to 64. And then subtract 10 on both sides, so we have 3x equal to 54. And then divide by 3 on both sides, so we have x equals 18. And then I would check the 18. So to do that, I'm going to plug in 18 into my original equation. So it will be 3 times 18 plus 10. That's under the radical, and then after that is plus 9. So the question is, when I do that radical and I add 9, do I get positive 1? And I will show you on the calculator that you do not. So we have the square root of 3 times the 18 plus 10. And then after the radical, we add 9. So notice that the plus 9 is not under the radical, and we get 17. Obviously, 17 does not equal 1, and so 18 is not actually a solution, so we actually have no solution. Okay, moving on to number 20. So on number 20, they're asking us to find what the true statement is of m and n. So let me go ahead and write down the equation that they gave us. So they gave us the mth root of x times x to the power of 1 over n, and that equals 1. Now, remember that we want to get all of the terms to have the same exponential form. So I'm going to switch this x to the power of 1 over m. And then now I can use the product rule, since the base is x and the same on both. So the product rule says if you're multiplying the same base, that you add the powers. So this will be x to the power of 1 over m plus 1 over n. And that equals 1. Now, you might be thinking, well, does that mean that A is correct? The power 1 over m plus 1 over n equals power 1. The powers are equal. Remember, the powers can only be equal when the base is the same, right? If I tell you 2 to the power of 3 equals 7, are you going to say that, well, 2 to the power of 3 equals 8. So are you going to say that 3 equals 1? No, right? That doesn't make sense. But if I change 8 to its power, it's 2 to the power of 3, 3 equals 3, that's correct, right? So the base has to be the same in order for you to say that the powers are equal. So when I put here 1 to the power 1, that doesn't help me. I need to write 1 as a base of x. So x to what power would equal 1? Well, I know that anything to the power of 0 equals 1. And so that means that 1 over m plus 1 over n has to equal 0. Now that the bases are the same, I can compare and say that the powers must be equal. So So actually it is not A. The correct answer is B. Okay. All right, moving on to number 21. So we have an equation here, x equals 2 times x plus 15 to the power of 1/2, and we need to solve it. So the first thing I could do is to get rid of that power 1/2, I can go ahead and square both sides. If I square both sides, 1/2 times 2 is going to be power 1. That'll get rid of the power 1/2 on the right side, and on the left side now I have x squared. Now this means that I do have a quadratic, so I'm going to get equals 0. So I'm going to subtract the 2x, and I'm going to subtract the 15th, so I can get equals 0, and I can solve this quadratic. So I'm looking for two numbers that multiply to negative 15 and will add to negative 2. And that would be 3 and 5, with the negative being on the 5. That way we add to the negative 2. So this would factor into x plus 3 times x minus 5. And so that means that x plus 3 could equal 0, or x minus 5 could also equal 0. When we solve over here, we get x equals negative 3, and when we solve over here, we get x equals 5. So now we have to check them. Remember, you always need to check all of these equations. So I'm going to plug in first negative 3 and check that. So the question is, does negative 3 equal 2 times negative 3 plus 15 to the power of 1/2? So I can just use my calculator and check it. So 2 times the negative 3 plus 15 is 9 to the power of 1/2 is 3. Does negative 3 equal positive 3? No. So this one is thrown out. Next, I can go ahead and check 5. So I'm going to plug in 5 for x. So 5, does that equal 2 times 5 plus 15 to the power of 1/2? So again, I'm going to use the calculator. I can go ahead and plug in 2 times 5 plus 15, and that's 25 to the power of 1/2, which is the square root of 25, which is of course 5. 5 equals 5, yes, that works. And so our answer is x equals 5. Okay, moving on to number 22. All right, for 22, notice that we have radicals on both sides. So normally when we have a radical equation, we try to get the radical by itself, and then we get rid of the radical by applying a power on both sides. But in this case, we have a radical on both sides. So we're not going to be able to do that. What we can do instead is just go ahead and square both sides so that I can at least get rid of this longer radical and get x plus 9 by itself. Now on the right side, I am going to have 9 minus square root of x multiplying by 9 minus square root of x. So it's two copies of that 9 minus square root of x. I can't just distribute the power, okay? The power rule only works when I distribute the power inside of the parentheses when I only have one term. So in this case, I will just do 9 times 9, which is 81. 9 times square root of negative x, which is negative 9 square root of x. Negative square root of x times 9, which is also negative 9 square root of x. So I can go ahead and just combine those two right now. That would be negative 18 square root of x. And then negative square root of x times negative square root of x, negative times a negative is positive. Any square root multiplied by itself is just whatever's on the inside. So now on the right side, we see that we can go ahead and subtract 81 to bring it over to the left side. And we can subtract x to also bring that over to the left side. Now that means that x will cancel on both sides actually, and 9 minus the 81 is negative 72. On the right side, we have negative 18 times square root of x. So I have another radical that I have to eventually try to get rid of. Before I do that and square both sides, I can divide by the negative 18 to get rid of that coefficient. So negative 72 divided by negative 18 is positive 4. And so then I have now 4 equals square root of x. So since square root of x is now by itself again, we can go ahead and square both sides. So 16 equals x is our solution. Of course, I don't know if that's a valid solution unless I check it. So let's go ahead and check it. So we would do square root of 16 plus 9. I'm just plugging in x is 16. And then ask, does that equal 9 minus the square root of 16? Now 16 plus 9 is 25. The square root of 25 is 5. And then on this side, square root of 16 is 4. 9 minus 4 is 5. So yes, this is a valid solution. X equals 16. Okay, perfect. Moving on to 23. So we're going to go ahead and solve this one. Now the radical or the side of the fraction with the fraction exponent is by itself. So we can go ahead and just raise this to the reciprocal power, because 2/3 times 3 over 2 will be just 1, power 1. So that means it's 1 copy of x minus 4. So we just bring that down. On the right side, of course, I have to do the same thing. If I did the left side of the power 3 over 2, I have to do the right side of the power 3 over 2. And I can just use my calculator, 5 to the power of 3, and then the square root of that, or just do the fraction 3 over 2. And that ended up giving me a decimal. So we don't want the decimals. They have to be exact values. So I am going to go ahead and just keep the 5, and then the 5 1/2. Since 5 to the power 3 over 2 is 1 and 1/2, there's one whole copy of 5 that's going to come out, and then the square root of 5 is going to stay on the inside. The other way that I could have done that is just 5 cubed is 125, and then it's the square root of that, and then simplify that square root. So on the left side, to get x by itself, I will add 4. And so we have whole number 4, and then plus that 5 square root of 5. Normally you put the number in front and then the radical behind it. And then we would divide by 3. And of course, when we divide all terms by 3. So you could either put it separate, 4/3 plus 5/3 square root of 5. Or you can just keep it all together as one fraction, 4 plus 5 square root of 5, divided by the 3. Either one is okay to write it. Now, I would need to check this one. To check it, I would plug it in. And to plug it in, I could use my calculator. We could do some basic work on the side over here, which is actually going to make it a little bit easier to check it. So we would do 3 times, and then it's 4 plus 5 square root of 5 over 3 minus 4 to the power of 2/3. The question is, does that equal 5? So in the inside here, we can simplify. 3 over 3 would cancel. So then we have 4 plus 5 square root of 5 minus 4 to the power of 2/3. Does that equal 5? And then the 4 minus 4 would cancel. So we just have 5 square root of 5 to the power of 2/3. Does that equal 5? And then now we can use the calculator. So it just makes it so that you have a little bit less to type into the calculator. So we're going to do the 5 square root of 5. And then raise that to the power of 2/3. And we got 5. So yes, this is a valid solution, which I squared it prematurely, but that's okay. So that was a valid solution. Very good. All right, number 24. I want to get the radical by itself, so that way I can square both sides. So I'm going to add x on both sides. So I have x plus 6 on the left side, since the variable normally goes first, and then the radical on the right side. Now that I have the radical by itself, I can go ahead and square both sides to get rid of that radical. But of course, when I square the left side, that means I'm going to have 2 copies of x plus 6 that need to be multiplied together. I cannot distribute the power of 2. I can only do power of a power rule, where I distribute the power when I have one term on the inside. So this will end up being x squared plus 12x plus 36. On the right side, of course, we just have 2x plus 15, which now we have a quadratic. So I'm going to get equals 0, so I could try to solve this by factoring. I would subtract x 2x from 12x, which would mean that that's 10x. And I would subtract 15 from the 36, which means that's 21. And so now to solve my factoring, I need to find two numbers that will multiply to 21 and will add to 10, which would be 7 and 3. So this would be x plus 7 times x plus 3. So we have two solutions. X plus 7 equals 0, which would give me x equals negative 7, and x plus 3 equals 0, which would give me x equals negative 3. Again, we must always check these, so let's go ahead and check the negative 7. So 6, does that equal square root of 2 times negative 7 plus 15 minus the negative 7? Now, 2 times negative 7 will be negative 14, plus 15 will be positive 1. The square root of 1 is 1, and the negative 7 will, of course, be positive 7. So this will be 8 on the right side. So does 6 equals 8? No. So negative 7 does not work. The negative 3, we need to check that one. So 6, does that equal the square root of 2 times the negative 3 plus the 15, and then on the outside of the radical minus the negative 3. So we have 6 equals, and then this would be negative 6 plus 15 is 9. And the negative 3 would be positive 3. And then the square root of 9 is 3. 3 plus 3 is, of course, 6. So this is a valid solution. So my solution here is negative 3. Okay. Moving on to number 25. So solve the equation. We have the cube root of 3x plus 7 equals negative 1. All right, so to get rid of the cube root, I'm going to cube both sides. Negative 1 to the power of 3 is just negative 1. And then the cube root and the cube cancel. So we have now 3x plus 7. Subtract 7 on both sides, we get 3x equals negative 8. And then divide by 3, we get x equals negative 8 over 3. To check our answer, we're going to go ahead and plug that in. So we have the cube root of 3 times negative 8 over 3 plus 7. And the question is, does that equal negative 1? So I can use my calculator. Well, 3 divided by the 3 would just cancel. So that would be, you could use a calculator, you could just look at it. 3 over 3 would cancel, so that would be negative 8 plus 7, which is negative 1. And so the cube root of negative 1 is negative 1. So yes, this works, and this is a valid solution. Okay, next up, let's do 26. So on 26, notice that they split up this fourth root, right? But both are being fourth root. So we can go ahead and apply the power 4 on both sides here, and that'll cancel out the fourth root. So now we have x plus 9 over 5x, and that equals 1 to the power of 4, which is just 1. Now, in order to get rid of this fraction, I do need to go ahead and multiply by 5x on both sides. 5x times 1 would just be 5x. So I have x plus 9 equal to 5x. And then subtract by x, we have 9 equals 4x. And then divide by 4, we have x equals 9 over 4. In order to check our answer, I'm going to go ahead and plug it in. And when I plug it in, I am going to go ahead and plug that into my original equation. So this would be the fourth root of 9 over 4 plus 9 over the fourth root of 5 times 9 over 4 and the question is, does that equal 1? So I can type it all into the calculator at once, or I can do the numerator and denominator separately. I'm going to do that just so I have a little bit less to work with at a time here. So I'm going to do the fourth root of 9/4 plus 9. And that gives me 1.8-ish something. Now, in order for this to be divided by the denominator and equal 1, then they have to be the same. So I should get for the other one also the same radical. If not, then it doesn't work. So 5 times 9/4. That also gives me 1.8-ish. So we got 1.8-ish divided by the same 1.8-ish. So yes, that equals 1. So this is a valid solution. Okay. Moving right along, we're going to go ahead and do number 27. So on 27, we need to solve this equation. Okay, remember that as long as the base is the same, then the powers are equal. And I can actually write 81 as a power of 3. Now, I know that I need to do this because in order to solve this, right, the bases have to be the same. So I could kind of just check a couple things, like I could do 3 to the power of 3, but that's 27. Okay, what about 3 to the power of 4? Okay, that's 81. So 81 is 3 to the power of 4. And if the bases are both 3, then that means the power of 4 must equal the power x plus 4, which means when we subtract 4 on both sides, that x must equal 0. Okay, for number 28, we have here the radical term. I want to go ahead and get that by itself. So I'm going to subtract 1/10 on both sides. That way I get the one with the radical, which is written as a fraction exponent, by itself. 0 minus 1 negative minus 1/10 would just be negative 1/10. Okay, now that I've done that, I can raise this to the reciprocal power, which would be negative 4. That way, I get the power to just be 1. And so then that would mean that it would be 1 copy of x minus 4, and then that fraction exponent goes away. Of course, if I did that to the left side, I have to do that to the right side as well. So I'm going to raise that to the power of negative 4. And I can use my calculator, negative 1/10 to the power of negative 4. And actually, I need to put parentheses around that. To the power of negative 4. And that is 10,000. 10,000 plus 4 would give me the solution 10,004. As always, we would check our answer. So to check this, I'm going to plug in 10,004 minus 4 to the power negative 1/4 plus 1/10. The question is, does that equal 0? So of course, the 10,000 minus 4 will be 10,000. So I can plug into my calculator 10,000 to the power of negative 1/4, and then plus 1/10. And it equals 1/5. So no, it does not work out. 1/5 does not equal 0. This is not a solution, and there are no other solutions, so there's just no solution on number 28. Okay, number 29. All right, we need to use U substitution to solve this one. And I can kind of tell that because we have a pretty complex equation here, where we have the same x plus 5 raised to the power first 2/3 and then 1/3. So I want to use U substitution, which makes it so that I have a quadratic equation. So my middle term would be the U by itself, which would be the x plus 5 to the power of 1/3. And then U squared would be the x plus 5 to the power of 1/3 to the power of 2, which would be 2/3. So I can replace this by U squared, and I could replace the second term by 4 times U. Of course, 3 is just 3, And now I have a quadratic equation using u. With this, I can solve. This would, by factoring, this would factor into u plus 1 times u plus 3, which should give me two solutions, u equals -1 and u equals -3. Now that's solving for u. The question is obviously with x, so I need to replace u back. So u equals x plus 5 to the power of 1/3. That equals -1. And then on this one as well, x plus 5 to the power of 1/3 equals -3. Okay, so now I'm going to solve those two x equations now to solve for x. So I'm going to raise both sides to the power of 3. That way I get the x plus 5 by itself, and -1 to the power of 3 is just -1. Subtract 5 on both sides, x equals -6. On the right side, I'm going to do the same thing, raise both sides to the power of 3. -3 to the power of 3 is -27. And that gives me x plus 5 by itself on the left side. And then subtract by 5, we get x equals -32. Okay, of course, we cannot know that these are correct answers unless we check them. So we're going to go ahead and check by plugging it in. So let's check -6 first. So we would have -6 plus 5 to the power of 2/3 plus 4 times -6 plus 5 to the power of 1/3 plus 3. The question is, does that equal 0? So -6 plus 5 is, of course, -1. And so let me take out my calculator here. So we have -1 to the power of 2/3. And then plus 4 times, of course, again, the same, -1 to the power of 1/3. And then plus the 3. And we got 0. So this one works. 0 equals 0. That's good. So -6 is a valid solution. I can go ahead and square that. Now, just because that one works, this doesn't mean that the other one automatically works. So we must check it as well. So I'm just going to plug in -32. Okay. Now, -32 plus 5 would be -27. So I'm going to just go back to the same equation and see if I can plug in -27 in here, if it'll let me. Insert a 7 with a parenthesis. Oops. Okay. And we got 0 for that one as well. Okay, so both work. When I checked -32, it also gave me 0, so that one works as well. So we have two solutions on this one. All right, moving on to number 30. So we need to solve this equation. We've got to get the radical by itself, so we're going to subtract 5 on both sides. The cube root of 2x minus 5 equals -2. And then this is the cube root, so to get rid of that, I'm going to cube both sides. -2 to the power of 3 will be -8. And on the left side, we just have 2x minus 5. Add 5 on both sides, we get 2x equals -3. Divide by 2 on both sides, we get x equals -3/2. All right, to check it, we're going to plug it in. So cube root of 2 times -3/2 minus 5 plus 5, does that equal 3? So the 2 divided by 2 would just cancel. So we have -3 minus 5, which is -8. The cube root of -8 is -2. -2 plus 5 does in fact equal 3. So this is a valid solution. Okay, for number 31, we need to get rid of the square root, which is already by itself on the left side. So we're going to square both sides. Remember, when you square, you must do 2 copies multiplied together. So this will be 1 plus 2x plus x squared. On the left side, the square root and the square cancel. So we get x plus 7. And this is a quadratic equation, so I'm going to bring everything over to one side. So when I subtract x, this will be x squared plus 1x. And then when I subtract the 7, it will be 1 minus 7, which is negative 6. All right, to solve this, I could do factoring. Multiplies to negative 6, adds to 1 would be 3 and 2. So it would be x plus 3 times x minus 2. And so I have two solutions, x equals negative 3 and x equals positive 2. Check them. I'll check negative 3 first. Negative 3 plus 7, does that equal 1 plus negative 3? Well, 1 plus negative 3 is negative 2. This will be the square root of 4, which is positive 2, so no, that does not work. Next, let's go ahead and check 2. So this will be the square root of 2 plus 7, and then does that equal 1 plus 2? 2 plus 7 is 9. The square root of 9 is 3. 3 equals 3. Yes, this one works. Okay, on number 32, we have a side length, and they said approximate the side length of an equilateral triangle with an area of 28 square inches. So they're giving us that the A value equals 28, and they're asking us to solve for S for the side length. So the side length will equal 2/3 times 3 to the power of 3 over 2 times 28, and then all of that is raised to the power of 1/2. So we can go ahead and solve this a little bit at a time. Or we can technically put it all in the calculator together at once. So we'll do a little bit at a time first, then I'll show you putting it all into the calculator, because the problem with the calculator and putting it all in at once is that you must make sure that you plug it all in properly with the right things in the right place, and that you don't accidentally, for example, put the 1/2 on the 28, because it's supposed to be around the whole thing. Now, this is asking me to approximate here, so I'm going to use decimal approximations. Normally, we would want to keep it as exact form with the radical or the fraction exponent, but in this case, since it says approximate, then I can go ahead and use estimated values. So the 3 to the power of 3 over 2 is approximately 5.2. So it's going to be 5.2 multiplied by that 28, and then that's going to be raised to the power 1/2. So next up, I can do the 5.2 times the 28, and that's about 145.5. And then the 145.5 has the power 1/2 and is also multiplied by 2/3. Now remember, we must follow order of operations, which is why I went inside of the parentheses first, and why I did exponents before I did the multiplication. So same thing is true here. I must do order of operations, so I must do the exponent before I do the multiplication. So just be careful, because you want to make sure that you follow the order of operations. So I'm going to take that 145.5 and I'm going to raise it to the power of 1/2, which is going to square root it. And we get roughly about 12.1. So now I do the 2/3 times the 12.1. And so now I could take that 12.1, excuse me, and multiply it by 2/3. And I get roughly about 8. And so that's my answer. Now in this, I could have also, like I said at the beginning, typed it all into the calculator at once. Let me show you how I would do that. So I'm just going to use this original one that I had written down and make sure that I follow it exactly as it is. So we have a 2/3, and then that's being multiplied in the parentheses 3 to the power of 3 over 2. And then that 3 to the power of 3 over 2 is being multiplied by 28. That ends the parenthesis, and then all of that has the power of 1/2. Okay, so that's the full equation. And then we click enter, and you see that same 8. All right. Okay. Number 33. Okay, so we have the distance in miles a pilot can see the horizon can be approximated by E of n. And then the function m of n approximates the distance that the pilot can see the horizon on the surface of Mars. Okay, so one is for seeing the approximate distance uh, with Earth using the Earth's space, and then one is using the Mars space or the surface of Mars. So the question is asking what is the distance that a pilot can see the horizon from an altitude of 10,000 feet from Mars? That's the question. So the question here is, which equation should I use? Because I have two of them, right? And notice that they are asking me what is the distance that the pilot can see the horizon from an altitude of 10,000 feet above Mars. So that's the equation that I should be using, is the Mars one. So the distance, that a pilot can see the horizon using Mars, and n, which is the plane's altitude, is 10,000 feet. So I'm going to plug in 10,000 for n. Now notice the equation for m of n is 0.75 times E of n, which n is 10,000. So I am going to need to use E of n just because m of n uses it, okay? But let's say it was 0.75 times n to the power of 1/2 or something like that, then I wouldn't even really need to have used E of n. But in this case, they are requiring me to use E of n in the equation for m of n. So I'm going to go ahead and fill that in. So E of n is 1.22 times the square root of n. And so m of n will be 0.75 times 1.22 times the square root of 10,000. Now the square root of 10,000 is 100, since 100 times 100 is 10,000. So this will be 0.75 times the 1.22 times 100. And I could type it all into my calculator at once. 75 times 122 times 100. And we get 91.5. So it's 91.5 miles, since the distance is being measured in miles. That's how far a pilot can see the horizon being at an altitude of 10,000 feet. Okay, for 34, we're going to go ahead and describe the transformation. Then we're going to find the domain and range. I don't know why they put it backwards, but it's okay, the range and the domain. Then we're going to go ahead and find the intercepts. And then we're going to go ahead and sketch. So we have to do all four things. So first, let's go ahead and describe the transformations. So notice on the inside, we are reflecting and we're also shifting. So this is going to be a shift to the right one. We do that first because we do the opposite order, right? Normally we would multiply, but since it's on the inside with x, we're going to do the opposite first. And then we're going to reflect. We're changing the sign of x, so that's going to be a reflection over the y-axis. And then lastly, on the outside, we're multiplying by 2/3, the y value by 2/3, so that's going to be a vertical compression by the 2/3. All right. The second thing they want us to do is find the domain and range. Now, this is a square root function, and the square root function is being reflected over the y-axis. Remember, the original parent square root function is over to the right like that. So if I take that and I reflect that over a y-axis, then it's going to look like this. It's going to be facing the other way. So the extrema is going to be here, and the arrow is going to be pointing the other direction. This is also shifted to the right 1 unit and then reflected. So if I shift it to the right 1 unit and then I reflect it, that means that the extrema is going to be at -1, 0. We can also confirm this by doing the graph. If we wanted to do the full sketch of the graph, we can do that at this point as well, which we can do by taking xy points and multiplying and applying the operations to them. So the original xy points are 0, 0, 1, 1, 4, 2, and 9, 3 for the square root function. So applying the rules, x needs to be added 1 and then multiplied by -1, which is the shift to the right 1, and then the reflection. And then for y, that needs to be multiplied by 2/3. So 0 add 1 is 1 times -1 is -1. 1 plus 1, 2 times -1, -2. 4 plus 1, 5 times -1, -5. 9 plus 1, 10 times -1, -10. For the y values, 0 times 2/3 is just 0. 1 times 2/3 is 2/3. 2 times 2/3 is 4/3. 3 times 2/3 is 2. So 2/3 is roughly about 0.7, and 4/3 is roughly about 1.3. That way I can plot them. So our new points is -1, 0, which that's our extrema, -2 and 0.7, -5 and 4/3, which is about 1.3, and -10 and 2. And again, that was our extrema point, so our arrow is going to point that direction. Make the graph a little bit more neat. There we go. Close enough. So that's the sketch. So now you can definitely clearly see that this is exactly what we had here for the extrema and the way that it was facing. So our domain is -infinity till that endpoint x value -1, and our range is from -infinity, or no, I'm sorry, the lowest point is 0 till arrow at the top infinity. Now last, we have to find the intercepts. So for the y-intercept, we're going to set x to equal 0 and solve for y. So our y value is going to equal 2/3 times the square root of -0 minus 1. This would be an imaginary, since 0 minus 1 will be a negative, so there's no real y-intercept. Okay, it would be 2/3 times the square root of -1, which is I, so it'd be 2/3 I. So it's not real, okay? There's no real. For the x-intercept, we do the reverse. We're gonna set y to equal 0 and solve for x. So the y value equals 0 equals 2/3 times the square root of -x minus 1. And so to get rid of the 2/3, I multiply by the reciprocal, 3/2. And when I multiply the left side, we just get 0. To get rid of the radical, we can go ahead and square both sides. 0 squared is just 0. So now we have -x minus 1. Add 1. Divide by negative. So we get x equals -1. We could also have confirmed that based on the graph that we just did. It's very clear that we already had the x-intercept because that was the extrema. Okay, that's number 34. Moving on to 35. So the velocity of sound in air is given by the equation where v is the velocity and t is the temperature. Write the formula for the temperature in terms of velocity. So whenever you see this, it's kind of more confusing because it's like, okay, should I solve for T or solve for V? It's already solved for V, so clearly it means solve for T. But if you just stop the sentence short, right, write the formula for the temperature. Saying in terms of velocity means that it's going to be like temperature equals, and then velocity will be a way that you find the temperature. So it will be in terms of velocity because you will have to do something with the velocity to find what the temperature is equal to. But it just means to get T by itself. So in order to get T by itself, I would need to first get rid of that multiply 20 on the front. So I'm going to divide 20 on both sides first. So that will be V over 20 equals the square root of 273 plus T. Then I have to square both sides. So this will be V squared over 20 squared, which would be 400, since it's 20 times 20. And then that'll get rid of the square root on the right side. So it just be 273 plus T. And then of course, to get T completely by itself, I just have to subtract 273. So T equals V squared over 400 minus 273. Okay. Moving on to number 36. Okay, so on 36, we need to go ahead and first describe the transformation. Okay, so the transformation inside with x, we're multiplying by 2. Remember, that is going to be the reciprocal. So it looks like we're multiplying by 2, but we're actually going to multiply by 1/2. So this means the horizontal compression. Next, on the outside, we see multiplying a negative. So if you're multiplying y by a negative, that means you're reflecting over the x-axis. And then we're adding 3, so that means it is a shift up 3. Okay, we do have here on the second thing that they're asking for is the domain and range. So in order to do that, I do want to make a rough sketch, okay? Now this is the cube root, okay? The original cube root function looks like this. But this one is being compressed horizontally. So if you imagine horizontally, take it and push it together. So it's going to look a little bit longer because of that. And it's being shifted up 3 units. Normally, the center is at 0, 0. This time, the center is actually going to be at 0, 3 because it's shifted up. Also, it is being reflected over the x-axis, which means that rather than it going that way, it's going to flip it over, and the curve is going to actually be in the other direction. So it's going to look something like this. No matter for that, it's always going to be the domain and range is negative infinity to positive infinity, but that's just how you would do the transformations for the rough sketch, because they do matter when you do the square root. Now, third thing that they want us to do here is determine the intercepts. So x-intercept and y-intercept. Again, for the y-intercept, you're going to plug in x is 0. So y equals negative cube root of 2 times 0 plus 3. And 2 times 0 is 0. Negative square root of 3 will be 0. Negative 0 plus 3 is 3. So we have y equals 3. Which makes sense because that is actually the center. And then for the x-intercept, we're going to plug in y is 0. So 0 equals negative cube root of 2 times x plus 3. Subtract 3 on both sides. Negative 3 equals negative cube root of 2x. Divide both by a negative to get rid of that negative 1 that's in front. We get 3 equals the cube root of 2x. Cube both sides to get rid of the cube root. 3 to the power 3 is 27. So 27 equals 2x. And then divide by x. Our x-intercept is 27 over 2. All right, the last step they want us to do is do the graph. So for the graph, we're going to go ahead and use the parent function values. So for the cube root, the values are -8, which the cube root of -8 is -2, -1, which is also -1, the cube root of 0 is 0, the cube root of 1 is 1, and the cube root of 8 is 2. Okay, so applying the transformations for x and y here, we're going to take the x value and multiply it by 1/2, and the y value, we're going to first multiply it by -1, which is the reflection over the x-axis, and then we're going to add 3 to shift it up 3. So -8 times 1/2 is -4, -1 times 1/2 is -1/2, which is 0.5, 0 times 1/2 is 0, 1 times 1/2 is 1/2, which again is 0.5, 8 times 1/2 is 4. For the y values, first multiply by a negative, then add 3. So -2 times -1 is +2 plus 3 is 5. -1 times -1 is +1 plus 3 is 4. 0 times -1 is 0 plus 3 is 3. 1 times -1 is -1 plus 3 is -2. 2 times -1 is -2 plus 1 is 2 times -1 is -2 plus 3 is 1. I think I messed up on the previous one. 1 times -1 is -1 plus 3 is +2. Okay, there we go. Okay, so let's go ahead and plot those. -4 and 5. -1/2 and 4. 0, 3, which is our center. Make that one a little bit bigger. 1/2 and 2. Plotted my 4 here a little off. This is 4. And then 4 and 1. All right, and then connect those dots. And there's our curve. Okay, number 37. So describe the transformation. So on the inside with x, we are going to subtract 3, which will be a shift left 3. And then on the outside, we're multiplying by 2 and adding 1. So in the correct order, multiplication is first. So that's going to be a vertical stretch by 2. And then add the 1, which would be a shift up 1. Okay, second, they want us to go ahead and find the domain and range. So notice that this is a cube root function, and it is not reflected. So it is going to be the original one. It's going to be shaped the original way. It's just that the center is moved over since it's shifted to the left, and up is going to be at -3, 1. But as far as the domain and range goes, it's just arrow on the left to arrow on the right. So domain and range are both negative infinity to positive infinity. Third, they want us to find the intercepts, so x-intercept and y-intercept. So for the y-intercept, we're going to set x to equal 0. So y equals 2 times the cube root of 0 plus 3 plus 1. 2 times the cube root of 3 plus 1. So that would be the exact value. In order to guesstimate it, I can use my calculator. And so I can punch it in as 2 times the cube root of 3 plus 1. And it's roughly decimal 3.9. For the x-intercept, we're going to do the reverse. We're going to set y to equal 0, and we're going to find x, solve for x. So to solve for x, I do need to first subtract 1. And the 2 that's multiplying in front, I need to get rid of that next, so I will divide by 2. So now I have negative 1/2 equal to the cube root of x plus 3. Now that the cube root is by itself, I can cube both sides. Now the cube of negative 1/2 will be negative 1/8, since 1 cubed is 1 and 2 cubed is 8. The cube root and the cube cancel. We get x plus 3, and then we just subtract 3 on both sides. So for my x-intercept, and I can use my calculator to do that quick fraction, negative 1/8 minus 3 is negative 25/8. Which if I want to write as a decimal, so I can plot it on the graph, I can use the 2 arrows right above the enter to estimate it to roughly about negative 3.1. All right, for number 4, they want us to go ahead and graph. So the last thing I'm going to do is do the graph. I can use the original parent function of a quadratic, of a cube root function, which the cube root of 1 is 1, the cube root of 8 is 2. That's the original table. We're going to apply the transformations to the x value. We're going to subtract 3, and then to the y value, first multiply 2, and then add 1. So for the x values, negative 8 minus 3 is negative 11, negative 1 minus 3 is negative 4, 0 minus 3 is negative 3, 1 minus 3 is negative 2, and 8 minus 3 is 5. For the y values, first multiply by 2, and then add 1. Negative 2 times 2 is negative 4, plus 1 is negative 3. Negative 1 times 2 is negative 2, plus 1 is negative 1. 0 times 2 is 0, plus 1 is 1. 1 times 2 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. And remember that our 0, 0 was our original center, so negative 3, 1 is our new center. So negative 11, I'm just going to extend the graph a little bit, negative 11 and negative 3. Negative 4 and negative 1, negative 3 and positive 1, that's our center, so I'll make it a little bit bigger, negative 2 and 3, and 5, 5. Since we also have the intercepts, we can plot those, so 3.9, so close to 4 on the y-axis, and negative 3.1 on the x-axis, so negative 3, a little less, or a little over the negative 3, because negative 3.1. Okay, plot all those points and connect them with a nice curve. There we go. All right. Moving on to the last question, number 38. We're doing all the same things, but this time with a square root function. So first, the transformations. Inside with x, we see plus 2, so this is a shift left 2. Remember, x is always the opposite. On the outside, we see multiplying a negative. Remember, that's going to be always a reflection. So if we're multiplying a negative on the y value, then that means that's going to be reflect over the x-axis. And then lastly, minus 4, so that's going to be a shift down 4. Now remember, the original function is square root function has the endpoint, the extrema, and then it goes up and to the right. This is being reflected over the x-axis. So if we imagine this being on a coordinate plane, if I reflect that over the x-axis, then it's actually going to be down and to the right like that, okay? And we shifted. It moved it to the left and down. So it's to the left 2 and down 4. But then the reflection happens. So we do the shift first, shift it left 2, then the reflection, so now it's down and to the right, and then it's shifting it down 4. So it's going to be at -2, 4, -4, and it's going to be down and to the right. Okay, so that's kind of like just a rough sketch, so we can get our domain and range, which we need to do next. So the extrema is at -2, -4. So domain would be the leftmost point is the x value of the extrema, -2, and that goes to infinity on the right side. And then for the range, we have an arrow at the bottom, -infinity, till the y value of the extrema, which is -4. Then the third thing they want us to do is find the intercepts. For the y-intercept, we're going to go ahead and set x to equal 0 and solve for y. So we have -√of 0 plus 2 minus 4. So this is going to be -√of 2 minus 4, which square root of 2 doesn't give me a whole number. So what I could do is that's the exact value, but I can approximate it using a calculator. So -√2, and then that number minus a 4. And we can use the 2 arrows to get the decimal version, which is roughly -5.4. Okay. For the x-intercept, we're going to do the reverse. We're going to set y to equal 0 and solve for x. So 0 equals -√of x plus 2 minus 4. Start by adding 4 to bring over the constant to the left side. Then that -1 that's in front, it's multiplying in front. We want to divide it to get rid of it. So we have that the square root of x plus 2 is going to equal a negative. But remember, whenever you take the square root of a number, that will not equal a negative. So there is no real x-intercept. Okay. If I was to find it and check, I would see that it didn't work. So there's no real x-intercept. Okay, so last step is the graphing. I could take my parent table for a square root function, which is 0, 0, 1, 1, 4, 2, 9, 3, and then apply the transformations for the new function. For x, we're going to subtract 2, and then for the y value, we're going to first multiply by -1 to do the reflection, and then shift it down 4 by subtracting 4. We're going to multiply -1, and then we're going to subtract 4 for the y value. Let's start with the x value. Subtract 2. 0 minus 2 is -2. 1 minus 2 is -1. 4 minus 2 is 2. 9 minus 2 is 7. For the y values, multiply by negative. 0 times -1, 0, and then subtract 4, -4. 1 times -1, -1, minus 4, -5. 2 times -1, -2, minus 4, -6. 3 times -1, -3, minus 4, -7. And remember, this was your extrema before, so this is your new extrema, which is exactly at -2, -4, like we thought. So let's plot that, -2, -4. That's our extrema, so let's make it bigger. Then we have -1, -5, 2, -6, and 7, -7. We can plot the y-intercept, which is about -5.4, so it's kind of like halfway between -5 and 6. And there was no x-intercept, which kind of logically makes sense as this is our extrema, and our arrow is going over, down, and to the right. So we can clearly see visually that there is no x-intercept. Okay, and that was the last question. So I hope this review solutions, worked out solutions help.